Welcome back, gang. We're going to look at the distance time graph booklet assignment and see how that's going to come into play. So recall in the first assignment that if we have a data table, time and distance here, as time passes and as distance increases, that means the object is moving. In this case, it's a deer. As time passes, the deer is moving, so the deer is going a certain speed. So a data table will tell us that. A better way of looking at that, though, is in terms of a distance versus time graph. So our time is plotted on the x-axis. Distance is plotted on the y-axis. And if you're plotting these points, which you'll have to do in the assignment here, there is one graph that you have to make. Just simply look at the time, look at the distance. 0, 0, 0, 0. A time of 1, distance of 13. Time of 1, distance of 13. There it is right there. Time of 2, distance 25. Time of 2, distance 25. So we can keep on going at those points, and it works out really nice for this when we can see that the line of best fit joins up with the dots perfectly. So that indicates, when that happens, uniform motion or constant speed. So the deer is moving at a constant speed as time passes by. And of course, constant speed is equivalent to the slope of the graph. That's what the previous assignment dealt with, looking at figuring out the slope of a distance time graph, and that results in speed. Over in this area here, we have the idea that y equals mx plus b. You've seen that in math class. If it crosses 0, 0 like that, that's equivalent to y equals mx. And notice how that is similar to finding d is equal to v multiplied by t, which we'll see later on in another assignment. We already looked at this on the previous assignment, that the same one, walking, biking, skating, etc. And of course, by looking at which one's the fastest, which one has the larger speed, we're looking at the largest slope, because slope equals speed on a distance time graph. So of course, the largest slope one here is biking, the next biggest slope line is skating, and the next biggest is walking. So just by looking at that, you can figure out what the speed is. Another example here, dealing with swimming. Of course, as time passes, these numbers are increasing in terms of distance, which means the person is moving, first of all. So that means that there is a speed that's happening. And over here, of course, we can see that freestyle has a larger speed than breaststroke in this case, just by simply looking at the table. At the table, we may not be able to gather that exactly, but over here on the graph, there's no mistaking that the largest slope line has the largest speed. The next example here, so slope is rise over run, and on a distance time graph, change in distance over change in time. So in figuring out the slope, for example, this is a Hummer traveling on a country road. As we see the minutes tick by, the distance in kilometers is increasing, so it is moving. There is a speed. To get what the speed is, figure out the slope of a distance time graph. Now, to figure out the slope, you can pick 2 points. You could have done this really easy and using 0, 0 as one of the points, but in this case, the textbook or this handout didn't do that. They chose this point here, which is 2.0 minutes, corresponding to 2.0 kilometers. So that's the T1, D1 point. And the second point over here, I believe that 9 minutes, 9 kilometers. Okay? So when looking at the slope here, slope is equal to rise over run, or V is equal to delta D over delta T. What I wish they would have put in here, which I'll get you to insert, is a change in D is equal to D2 minus D1. A change in T is equal to T2 minus T1. So in setting that up, you can just simply pull your numbers in. D2 and D1. D2, let's see, here's T2 and D2. So my second distance minus my first distance, 9 minus 2. That's what's up here. And then my second time minus my first time. T2 is 9, T1 is 2, 9 minus 2, we get that. And of course we get 7 over 7, which works out to be 1 kilometers per minute. So of course, over here at the end here, in summary, you may want to highlight this. The speed of an object in motion can be determined from the slope of the distance time graph. So it only works for a distance time graph. The slope of that gives you speed. Now the questions to work on, the circled ones here, explain your words, why a graph is sometimes more useful than an equation. I kind of talked about that already. Think about the visual aspect of it. Easy question here. What does the slope of a distance time graph give you? I just mentioned that. And then what interpretation can be made about a moving car on a distance time graph that has the following characteristics? Remember, slope is equal to speed. So whatever's happening to slope, that's what's happening to speed in each of these cases. So just a real easy way is just to change the word slope with speed and you'll get your answer. Number 4, you can omit. Number 5, you'll have to get a piece of graph paper because I want you to plot this out. Distance versus time, so you'll have that labeled on there. Hopefully you'll get a straight line graph. So plot the graph. Use your graph, find the distance traveled after 5 minutes. So for that you just read on the graph. So you'll have your graph there. Go over to 5 minutes, go up until you hit the line, and then go across, and then you'll see when that in fact hits. And then vice versa, find the time required to cross the bridge. The bridge is 12.9 kilometers long, so when you have your graph on your distance, go to 12.9, go across until you hit the line, then go straight down, and that'll give you your time that was involved with that case. And then what is the speed constant during the car's trip? How do you know? So by looking at the graph, the shape of the line, you should be able to determine whether it is constant or not. Over here, calculate the slope of the graph. What does the slope mean again in reality here? And then what is the speed of the car in kilometers per hour? Now you'll have kilometers per minute, so you'll have to change that into kilometers per hour, and you'll do that by simply, so it's kilometers per minute. So to change that into kilometers per hour, just simply multiply by 60. Because there's 60 minutes in 1 hour, you'll be able to change that into kilometers per hour. And then the last question here, number 6, 2 people on bicycles, Jerry and Tom. Just by from a qualitative observation, which rider is going at a faster speed? So you should be able to see that from the graph automatically. Calculate the speed of each rider by determining the slope. So a nice little one here is you can use this point here. You can cheat and say the first T1 and D1 are both 0. So then figure out T2 and D2 for Tom, figure out D2 and T2 for Jerry, and then you'll be able to figure out the slope for each one of them. And then if one of the bicycle riders suddenly stops, how would the graph of the rider change? What would that look like if all of a sudden they stopped? Would it be an increasing straight line, or what change would result? So there you have it. That should help you out and help you finish that assignment for this booklet.